Okay, so here's the unit circle where we left off yesterday. Agreed?
Yeah. Stop recording us because we're not.
I had started. So here's my unit circle. So we filled in 30 degrees, which is pi 6 radians, 45 degrees is pi 4, 60 is pi thirds, 90 is pi half. The coordinates are radical 3 over 2, 1 half, radical 2 over 2, radical 2 over 2, 1 half, radical 3 over 2, and 0, 1. Okay, so everybody's good with that?
Yes.
Now, then the rest is just filling in the rest. So what I usually do when I fill in a unit circle is I go with the degrees first. And I just start at 0, 30, 45, 60. It's almost like we're going up by 15, but we're skipping a 15 every once in a while, right? Like we don't actually write 15. But I go 30, 45, 60, skip 75, 90, skip 105, 120, 135, 150, 180, 210, 225, 240, 270, what's this, 300, 315, 330, and 360. Agreed. Then I go through and I fill in all the radians, which is probably the hardest part of the unit circle, is filling in the radian measures, right?
Is there really a pattern to it? Because I like.
There's not necessarily a pattern. Well, yeah, I mean, I'll show you what I do. So you've got pi 6, pi 4, pi thirds. You should know those. Okay? Very important. So what I do is I kind of break the unit circle up into chunks. Or spokes even. Everything except the 45s, right? That breaks the entire circle up into 12 equal-sized pieces. What is the angle of each piece? 30 degrees, or how many radians? Pi 6. So I just start counting by pi 6. This is 1 pi 6. Here, let me draw it out. This right here is 1 pi 6. Well, there you go, 1 pi 6. This is 2 pi 6. What does 2 pi 6 simplify down to? Yeah, 2 6s 1/3, and so that's why we have 1 pi thirds. This right here is 3 pi 6. So what does 3 pi 6 simplify down to? Pi halves. This is 4 pi 6. It simplifies down to what? 2 pi thirds. This next one is 5 pi 6, which does not simplify, so we write 5 pi 6. And then the next one is 6 pi 6, which is just pi. Next we have 7 pi 6. Then we have 8 pi 6, which simplifies to 4 pi thirds. Oops. Next we have, what is this one? What was I on? 9 pi 6, which simplifies down to 3 pi halves. This is 10 pi 6, which simplifies to 5 pi thirds. And then our last one is 11 pi 6. And that's it. Oh yeah, and then the last one's 12 pi 6, which is 2 pi. Oh yeah, and this one was pi. Yeah, there you go. Okay. Okay, now, we've only done the multiples of 30. Those are all the multiples of 30. I got to go back through and fill in the multiples of what? 45. Well, multiples of 60 are multiples of 30. So if I just do that, I'm good. So now I go through and do the multiples of 45, of which there are some angles that are multiples of 45 that were also multiples of 30. Agreed? So 45 is pi fourths. This angle right here is 2 pi fourths, which simplifies down to what? A halves. This one is 3 pi fourths. The last one is 4 pi fourths, which is pi. 5 pi fourths. 6 pi fourths simplifies down to 3 pi halves. 7 pi fourths. And then the last one is 8 pi fourths.
But because our quiz on Friday will be timed, it's probably better.
Yeah, I mean, it's not necessarily time. You'll have plenty of time to fill this in however you want. Just the more time you spend on the unit circle, less time on the quiz. But I don't think time is actually going to be a major factor Friday. Okay?
So we could do that.
Yeah. That's how I do it. That's how I fill it in. I mean, even that, you should be writing pretty much the whole time. You know, because you're just going through. Maybe it might take you a little time to simplify, like 2 pi 6 in your head. I mean, that might take a little bit of time where your hand's not writing. So yeah. And then the rest is just using symmetry to fill in the coordinates. So you got -1/2, radical 3 over 2, negative radical 2 over 2, radical 2 over 2, negative radical 3 over 2, 1/2, -1, 0. Negative radical 3 over 2, -1/2, negative radical 2 over 2, negative radical 2 over 2, -1/2, negative radical 3 over 2. This is 0, -1. This one is +1/2, negative radical 3 over 2, positive radical 2 over 2, negative radical 2 over 2, positive radical 3 over 2, -1/2. Dalton, do you have a question? If you didn't simplify it, I probably would not get points off of that, but I'll go as I'm grading. I'll take a little bit less of you, but not take a point off. Is that worth it?
Yeah. You already think like really low.
But not Dalton. I think pretty highly of Dalton. Yeah. So that's it. Now, here's what I would do if I were you. I would take that unit circle you've been spending so much time filling out and getting right, and I'd throw it away. No. What if there's a mistake on there you just haven't noticed? If somebody knows what to think. I would throw that away. I'd go home, throw that away, go out to the interwebs, the Googles, Google unit circle. I recommend Wikipedia's unit circle. That is great. And print one of those out. That way you know you have one that's correct. And use that. Have that in your notes. And use that as you study. Because what if there's a negative sign missing in here? I don't know. There might be just something slightly wrong. Great to practice. You can go to that embeddedmath.com, print some blank ones to practice on. That'll be the same exact one I used on Friday's quiz. But as far as one you actually use to do your homework questions, I would get one that's printed and formatted nicely and is correct.
Has anyone ever tried for now, like, they already had it put in, they're like, oh, it's an embedded math one. So they just grab out their embedded math one that's already put on there. Like,
ooh, that's good. I'm going to have to make mine unique somehow.
I was just curious.
Yeah. That's good. I hadn't thought of that. That's nice. I'm just going to put a... Yeah. Molly, man, why did you expose all the cheating we wanted to do? Horrible.
For like tests and stuff, are you gonna give us like that, or are we just gonna figure it? Like
On this Friday's quiz, I'm going to give you that. On the rest of the quizzes, you'll have nothing.
At all? Like we
At all.
have one that we would fill out ourselves?
Unless you want to spend the first couple of minutes of the quiz making it small enough in the corner. No.
I thought you said you were going to give us an accurate one, right?
Yeah, so I'll give you one that is, right.
Only for that quiz.
Only for this Friday. After that, you need to answer questions. Like here, ask me a trick question.
I already did this morning. I answered it.
What is the cosecant?
Because I'm slow, and I'll go through my thought process. I don't have it memorized. I figure them out.
What is the cosecant of pi over 4?
The cosecant of pi over 4 is right over 2. That was an easy one. Most of them are easy ones, so give me a harder one. The secant of 330 degrees, so 330 is a positive radical 3 over 2, so 2 over radical 3, which becomes 2 radical 3 over 3, because you radical over the denominator.
Wait,
So
what's the answer? Yeah, you're slow.
I would accept 2 over radical 3.
No, it's not.
The hard ones to me are if you give me like 5 pi 6.
No,
because I don't know.
it's negative 1/2.
Secant is reciprocal cosine.
Oh yeah.
Wait, if you give pi 5 half, what?
Like if you said like, what is the cotangent of 5 pi 6? No, let's do that one.
What's the cotangent of 5 pi 6? Oh my goodness. 5 pi 6, that's the negative radical 3 over 2, comma 1/2, so the cotangent is a negative radical 3. Yep. It's negative radical 3 over 2 divided by 1/2.
We list all of them 62.
But that's what you'll have to do. You'll have to figure those out in your head. Look at. You might sketch a little bit of that angle, but here's what I do. I have that blank unit circle memorized in my head. I picture it. I'm a very visual learner. I see the unit circle, but I don't see the numbers. So when you say 5 pi 6, I find where 5 pi 6 is, and I know that it is the farthest to the left, shortest triangle. Farthest to the left means the x-coordinate's got to be negative radical 3 over 2. Shortest height means the y-coordinate's got to be positive 1/2. And once I have those coordinates, I start dividing them and flipping them and doing whatever you need to do for your church.
Does that make sense?
Then you slow it down.
Yeah, right. What is that?
Compared to another math teacher that might legitimately just have the thing memorized and just rattle them off,
That's a lot to memorize.
it's a lot to memorize. To me, it's not, I don't memorize the unit circle, I memorize how to recreate it. Does that make sense?
Yeah.
That was a compliment. That was slow, then where am I?
Yeah, I'm like,
We knew that. All right. Okay, so let's just start, now that we know how to create the unit circle, let's start answering questions about it. Like,
can we not do this?
Yeah, can you not?
Yeah.
on your own, quietly, in your head, I'll be listening telepathically. What is the cosine of 240 degrees? Give you a couple seconds. It absolutely is. Now here's the rule. If it's not an angle on the unit circle, and it is not coterminal to an angle on the unit circle, you gotta use calculus. You can't tell me about it. Actually, that's kind of false. We will eventually learn how to find the cosine of 15 degrees in exact form by hand. So there are some angles that we can. But if I say what's the sine of 37 degrees, you gotta just give me a calculator. Okay? Alright, what you get? What's the cosine of 240? Negative 1/2. That was this right here. Yeah, I mean, look at the unit circle. Right now, I still expect you to look at the unit circle as you get used to it, as you're still memorizing it, memorizing how to use it. I expect you to still reference the unit circle. But come next Friday,
Oh, next
I
Friday,
expect
not
you
this
to-
Friday.
No, this Friday, memorize the unit circle so you can recreate it, and then learn how to use it when you have a tangible unit circle in front of you.
Oh, but that's just looking at it.
Right.
Okay.
Then come next Friday, you should be able to answer questions like this, completely out of your
Wait, so
head.
like, no calculator?
No
For
calculator.
this Friday, I'll bring, no. Like, you know,
How to make it,
know that, like,
and how to use it.
x-coordinate- Yeah. So like the x-coordinate is cosine and then the
Right.
y-coordinate is sine.
Absolutely. Absolutely. Here, let's do a tangent. What is the tangent of 2 pi thirds radians? And again, you're eventually going to have to do that without being able to look at the unit circle. You got to say, all right, 2 pi thirds.
Right now, you.
Wait, what did you
That's
have?
negative 1/2 comma radical 3 over 2. So then divide it by the x.
Wait, hold on, I'm working. Wait.
When you, instead of telling you to get the answer, do something discreet, like, I don't know, some sort of gesture. Like the big nose pick. What? Tangent 2 pi thirds. Tangent of 2 pi thirds. Answer! Negative radical 3. Okay, again, because the denominators are the same, when you divide them, they cancel. So you're just dividing numerators. This is just radical 3 divided by negative 1. Boom. Negative radical 3. What is the cotangent of 120 degrees?
I know.
Yeah. You.
No, here's why it's easy. A lot of you are treating it as if it's a new, different problem. It's the same problem. You just take the reciprocal because it's the reciprocal function. It's this. 120 degrees and 2 by thirds are the same angle. So if tangent is negative radical 3, the cotangent is going to be the reciprocal of that. And cotangent is x divided by y, so you get negative 1 divided by radical 3. That's it. But how many of you want to practice rationalizing the denominator? Because if you're an AP Calc AB next year, you're probably going to miss points if you leave negative 1 over radical 3 as your answer. So what do you multiply top and bottom by to rationalize that denominator? So you get negative radical 3 over the square root of 9, which is just 3. So I would accept either of these, do not care. I highly recommend you get used to what they both look like. Because those can, when I make tests, because here's another thing we're going to eventually have to learn how to do. Are you ready to, this will not be on Friday's test, maybe, I don't know. I haven't decided. What if I ask you, the tangent of what angle gives me negative radical 3 over 3? I'm not only going to give you angles and what's the output, sometimes I'm going to give you the output and you got to find me the angle. So what angle gives you a negative radical 3 over 3? The reality is there are how many solutions to this equation? Infinitely many. All the coterminal angles. All of them.
So what would your answer be? Infinite?
But it's not all numbers, right? 30 doesn't work.
120?
So you would say anything coterminal to 120, but also anything coterminal to 300.
What if we just said
Is it 120 and 300 and has the same cotangent or tangent?
What if we just
So
said,
you say anything coterminal. And there's a fancy way we say anything coterminal to. So we'll learn that when we get there. We're not ready for that. But my point was. I'm sorry. It's 150. Whatever. My point is, the solutions are 150 and 330 and all their coterminals. My point is, when I make a quiz and I create a question like this, I have the denominator rationalized already. So if you look at this and don't realize it's the same as that, because that's what you actually find when you look at the unit circle, you're going to be in trouble. So you're going to want to be comfortable with, and it's just 2. It's 1 over radical 2, and it's 1 over radical 3. Those are the only 2 you really have to be comfortable with. So I would get used to seeing this and immediately saying, oh, that's actually 1 over radical 3. Okay? All right, let's answer some more. Let's do, what is the secant of 5 pi thirds? Don't shut it out. You shut it out, Molly will shut it you. Probably worse. The secant of 5 pi thirds. Everybody give it to me. 2. Find 5 pi thirds. Secant is the reciprocal of cosine. Reciprocal of 1/2 is 2. Okay? Reciprocal of 1/2 is secant is the reciprocal of cosine. It's weird. Say since the function flips, so does the naming scheme. Secant doesn't have a co, it goes with cosine. Sine doesn't have a co, it goes with cosecant.
So, only question, right? We got secant. We get 1 to the right. Cosine 5 pi over 3 equals, and then what's it?
Like partial term?
We get full credit.
Or a combination. Well, it's valid method, which that is. Yeah, that's fine. Okay, secant 5 pi thirds is 2. How about, what is the sine of 270 degrees? Everybody give it to me. Negative 1. Then you're going to want to practice some extras because you want to get a lot faster than that. On Friday, you'll have the circle, so you want to be able to just zoom right in on it
find 270, find the y coordinate, done. It should literally take you seconds. Okay. What is the cosecant of 2 pi radians? Don't say it. Don't say it. A little bit harder. A little tricky. Don't say it. You know, everybody, don't say it. I'm just reminding everybody not to say it. Okay, everybody, still don't say it. All right, say it. Very good. Not zero.
Okay. Because it's cosecant, you either want to look for, first of all, 2 pi's right here, you want the y coordinate, because that's 9. But you want the reciprocal of it. The reciprocal is 0. 0 is 0 divided by what?
1.
Something not 0. Anything not 0. Well, the reciprocal becomes something not 0 divided by 0. That's undefined. So the reciprocal of 0 is undefined. So cosecant 2 pi. When we learn to graph these functions, there will be a vertical asymptote, x equals 2 pi. For the graph cosecant. Okay?
Different coordinate grids to graph functions.
You aren't going to make your x's go up by 1s. You're going to make them go up by pi halves or pi fourths. No, it's still a rectangular grid. You just label your axes differently. The key to graphing trig functions is labeling the axes. You can literally draw the same shape for every graph, and it's just labeling appropriately. Let's do another one. Let's do, we haven't done many fancy division ones. What is the tangent of 390 degrees?
What is the, right down here, what is the tangent of the angle 390, not even on our unit circle, what is the tangent of 390 degrees? Don't say it. Don't say it. 5 over radical 7.
No, it's not.
No, it's not. Hey, Bruce.
Oh.
You got that. You did the coaching. All right, what is it?
Good, but I saw 1 over radical 3 or radical 3 over 3. So the key here,
Is 390 actually on your unit circle?
No.
No, but what angle coterminal to it is 30. Okay? So to find the tangent of 390, you can actually find the tangent of 30. They will be the same, guaranteed. Okay?
It always goes from the,
You always do what?
it always goes from the,
Positive x. Always. Initial side. All these angles are in standard position. So you do 1/2 divided by radical 3 over 2. You ignore the 2's because they cancel. 1 divided by radical 3. Or you can write it as radical 3 over 3.
very nice. Right. So shall we get crazier with those? Let's do it. What is the secant of -5 pi fourths?
Yeah, don't say it. Secant of -5 pi fourths. Negative means instead of rotating counterclockwise, you rotate clockwise. Yeah. Right. Your all the angles you have written are positive, so you expand them out. So you got to start here. You go -5 pi fourths and see where that's at, and then you do the coordinates. So secant -5 pi fourths.
Don't say it. Wait, okay, hold on, I got this.
I got it.
Okay.
All right. What is it? Negative radical 2.
If you simplify it, it simplifies down to -2. Here we go. Here's how.
negative 5 pi-4ths. I start here, and I want to go 5 pi-4ths, but I want to go in the clockwise direction. So I go 1, 2, 3, 4, 5. It's this angle right here.
Oh, I thought it was
Negative 5 pi-4ths this way. Secant the reciprocal of this. So 2, negative 2 over radical 2 is just negative radical 2.
I just thought you followed that line.
What line?
So wait, does negatives go counterclockwise? Or clockwise?
Clockwise. So negative 5 pi-4ths. Here's 1 pi-4th, negative 2 pi-4ths, 3, 4, 5.
I thought you just followed that line.
So you're saying you went to 5 pi-4ths, but you went in the negative
Yeah, that's
direction?
what I did.
That's a polar coordinate.
Ah,
That is something we kind of do a long time from now. A negative, so what you did was a positive angle, but with a negative radius. A negative angle is clockwise. So, it's here.
How do you get rid of your 2 on this?
Well, what you end up with is negative 2 over radical 2. Isn't the number 2 the same thing as radical 2 times itself? Right? And don't one of these cancel. But more importantly, wasn't this fraction, didn't I emphasize yesterday that you need to know that this fraction and this fraction are the same? So I didn't actually take the reciprocal of this. Even though that's what I saw in my unit circle, I didn't take the reciprocal of this. I took the reciprocal of that. So it's radical 2 over 1.
Will this, like, work, ever besides this time? I just went to, 5 pi over 4. I did the secant of that.
Oh, it's already there. No.
I got it.
In theory, you could learn of the relationship amongst all those, but there's so many different scenarios, you'll probably mess them up. Yes. So we start right here. And then I need to rotate clockwise this direction 5 pi-4ths radians. So here's 1 pi-4ths, right? Here's 2, here's 3, here's 4, and then here's 5. So that's negative 5 pi-4ths.
Can you, because I was trying to simplify 1, the secant is 1 over x, so it would be 1 over negative radical 2 over 2.
Right.
How do you, so, I mean, I know you got the answer of maybe.
Okay, so you think of reciprocals like this. Reality, just take a fraction and flip it, bottom flip top. But you could do like this. Well, how did you learn in elementary school to divide fractions? Multiply by the reciprocal. So does 1 divided by that fraction, doesn't that become 1 times the reciprocal?
Here's my next question. Since this was 5 pi over 4, and you would go by pi over 4, if it was something else like...
So let's say I wanted to know what is the cotangent of 57 pi over 6.
I would go pi over 6 now, not pi over 6.
And you do 57 of them.
Oh, God.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. What I would do is I go, there's 12, 24, 36, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57.
Oh, nice.
No, that can't be. That's simplified. I know. That's what you do. That's what I do.
How could you possibly...
Well, 24, 36, 48,
Okay.
49, 50, 51, 52, 53, 54. 57 is 6 simplified down? Do I not know this?
Yeah. Oh, it does.
Yeah.
It does.
Why don't you multiply 65?
Because that's 3 times 9.
Oh, so that's actually 19 pi third.
Yeah.
How about that?
But that's
not-
yeah, that really doesn't help.
No, it's 19 pi halves. It's 19 pi halves.
Great, because you forgot it.
So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19.
So that, I picked a bad example because that actually is the same thing. That's the same thing as 19 pi halves.
But then how is that the same thing as 2 pi?
It's not. 19 pi halves and 3 pi over 2 are different angles. They're coterminal. Correct. These angles are the same, because that's just simplifying fraction, but they're not the same. Now, this is a true statement. Cotangent 19 pi halves, and this is, so this is a true statement,
Yeah.
but this
This is not equal now.
is not. So guess what's going to happen a lot when we start solving some equations using trig functions?
Extraneous solutions, inverses that don't quite work properly, stuff like that.
All right, you guys are good. We are totally great. I mean, we made up our own examples, but these are the same. You know, what are the 6 trig functions of negative pi thirds? So, yeah, you're good to go. This homework, we are finished. I could collect it tomorrow. We'll start on the next section tomorrow, and hopefully get even more stuff I can pile onto your quiz Friday.
Or not.